I wanted to give you a little bit of an idea of what we're going to be doing and what the microcontroller here is capable of. And so we have our microcontroller here. I have it connected up to my computer. On the right-hand side here, I have Code Composer Studio set up. It looks a lot like Eclipse if you're familiar with Eclipse, and that's because it's built on it. I believe this is version 8.2, and so File, I'm just going to do a new project. Okay, and this gives you an idea. I have to select the right microcontroller. It might work if I'm identifying it, and it's not finding it, okay? And I kind of expected that one. But what I'm going to do here is, it's a G2553, so I go down and I find the G family, which is there, and then there's a whole bunch of different. So a microcontroller is a little itty-bitty computer. So there's my G2553. I have to give it a name, and so this is going to be my first code. I don't like to have spaces in my code names. I'm going to make it an empty project with C in main.c, and so we're going to be programming code with C, and it's going to pop this up. We're going to have Project Explorer on the left-hand side. And the Project Explorer gives us, we can have multiple projects in here. And we have main.c, which is displayed over here, and so this is a lot like I said, this is a lot like Eclipse. It doesn't include MSP430.h, and so this is all C language, and I'm going to do something really quickly that's not going to make a lot of sense to you, but so this is the example code that starts. And what's funny is the microcontroller is constantly running. It doesn't stop. And so it's not like a program where you run and it returns something. It's always there. And so I don't like that little return zero that it has. And let's just get some code onto this. And what I'm going to do first is I'm just going to make a while one. It will never get out of this loop, and for good reason. It's going to run code. It's an independent system. It's going to be constantly doing something. It can't stop. If we power it up, it wants to do something. That's what its internal hardware does. And so I just made a while one loop. I have two LEDs, and if you look closely, and if we look closely at this image that I've got here, it shows us that, well, first of all, we have a whole bunch of what are called GPIO pins. GPIO stands for General Purpose Input Output. Okay, they can be ones or they can be zeros. They're logic levels. We can control them as ones and zeros, and that's what I want to show you. So initially with this, and so let's come back here and I have to set them. The GPIO pins can be an input or an output. And so the first thing that I'm going to do here is I'm going to take. This is a predefined thing, P1 dir. I'm going to make it equal to, we'll change this in the future, but 0x01. That's a hex value. I also could have said 1, make pin 1.0 an output. And so this is a little confusing because we have to realize that that's in hexadecimal in P1 dir. We have to talk about hex just a little bit. But let's go for it. If it makes you feel better about life, this is the same as saying 1. And I just want to make pin 1.0, so there'll have to be some explanation on this a little bit later. 0.1. And the other thing that I'm going to do is P1. This controls whether that pin is an input or an output. And now I want to control whether the pin is off or on. Now, pin 1.0, as I just pointed out from here, is pin 1.0 is connected over here to LED 0 or LED 1. 1.0 is connected right here. There's an LED right here. 1.6. So this pin is connected over here. And so if we go back, P1. This is another predefined thing. P1 out is equal to 0x01. That should turn on the LED. And so when I run this code, and then it's going to get stuck in this while forever loop, and nothing else is going to happen. The microcontroller is just going to spin in a circle. And it doesn't hurt it to do that. It just warms up. You could put it to sleep, but that's for a future class. And so this runs. I don't want it to tell me about low power options anymore. It loads the code. As long as I'm plugged in, it's going to sit here and it's going to turns our code into hex values and dumps it onto the flash memory of our microcontroller. Now it's loaded it, but I have to press play. So to get there, I had to press debug, okay, and it got there. And then I'm going to press play, and sure enough, it turned on what's the red LED. And I know it just looks like white on that really crummy camera, but that gives you the intro to what we're going to be doing. Okay, so that's first things first. Let's go back here to the code, okay, and I'm going to do both 1.0, I'm going to do pin 6. Pin 6 is really weird because it's out there, it's a 4. That doesn't make quite sense yet, but I'm going to turn both of those on simultaneously. Let's reload the code, so we have to reload the code, it doesn't do it automatically. It's going to compile it, it's going to dump it onto the microcontroller, it's doing that right there. I'm going to press play. And now both of them are on. I don't know if you could tell the difference as that happened. And I'd have to go back and review the video because I wasn't paying attention to the camera at that particular time. But if I look, and I'm actually looking with my actual eyes, I see both a green and a red LED on. And this seems really handy and interesting. What I really want to do in this particular case is I want to do something where I'm going to say P1 out is equal to 0, and then I'm going to have to do something that's kind of weird. I'm going to declare a variable. It's a horribly named one because how many countdowns are there in code? A whole bunch. We'll start there. Countdown. I'm not going to predefine it. I'm going to say 4, and I didn't just declare an int, I declared it volatile, and we'll talk about this here in a second. 4, countdown equals 0, countdown, let me see, countdown equal to 0, countdown less than, I'm going to do hexadecimal again, FFFF. I don't even like that. That's because I have to make this unsigned. A little bit more about binary values here. Countdown plus plus. If this is completely confusing to you, you need to go back and review some C. And I'm going to put and what that's going to do is it's just going to cause delay. And I'm going to do this again. But instead this time, I'm going to do 0x41. So what should happen? Well, we're causing actual physical time delay to happen here and happen here. And then we're turning off and on, and then it goes back through the loop. And so what you expect to happen at this particular case is what? Well, what we'd expect is that it would blink. And we'd hope it would. And so let's see if that's indeed what happens. We're going to press play. And it does. So it looks like 0xFFFF countdown to that for loop causes about a 1 second delay. 1 1000, 1 1000, 1 1000. Okay, so we've made our first blinkety blink code. And there's some other interesting things that we can do with this one. Okay, I'm going to make this 0x01. I'm going to make this 0x40. Okay, and we are going to reload the code. Another way to do this, so there's the play button that's going to happen, but I can also I'm going to press F8 instead. F8, and it'll go. And now I've got railroad lights. You can see that it's blinking between the red and the green, swapping back and forth. And that's because it's turning on one and then the other sequentially. And so this is our first code. You don't necessarily need to know on all the things that I put in front of you for this, because that's what we're going to kind of look at next is what kind of values we have to deal with. And so I think that's all for this video. This is going to be a really quick one about our first example piece of code on an MSP430. One last thing that I want to bring up about the microcontrollers is that it's not the only one. And some of you probably played with stuff in the past. There is a Raspberry Pi, for those of you who play with those things. I kind of like the MSP430 for educational purposes. It teaches you a lot about how the internals work. It's the one that I use primarily in my research right now, just because it's so easy for me to use anymore. I'm so familiar with it. But some of you played with an Arduino, it's the same thing. And the important part about this is the code that we just wrote exists on here. This is bigger chip. This has an ARM processor on it. It's an it's a Raspberry Pi. It'll run a Linux type operating system, okay? And it has an HDMI out and the actual USB ports and a LAN port. And so we can actually hook this up to a keyboard and mouse and everything. This would be hard to hook up to a keyboard, mouse, or display of any kind. This one is really easy. It works out of the box. There's an operating system that comes with it. We can connect it to our network. But it has the advantages of these pins. And as opposed to the computer that I'm recording this on, I don't have any access to what are called GPIO pins. I can't control LEDs like I'm controlling them so nicely on that red board. But this one, this is a computer. This is pretty much a full-fledged computer. So if you get the newest version of the Raspberry Pi, it ends up being very beefy. Like a full-fledged computer, but you still have access to all these GPIO pins to control things high and low, which is pretty incredible. And there's a whole range of things in between. I had a student that I was talking with yesterday who brought up and we looked at the ESP8266, I think is what it's called. This is a different microcontroller. This one has a Wi-Fi chip on it. They're about $4, okay? And that's just the Wi-Fi chip portion of it. But you can buy them with a microcontroller and a programmer already on there. There's a version that I use called a Node MCU, and these are programmed up through the Arduino interface. And these aren't super powerful. Here's another one that I like to use. This is called a Teensy Microcontroller. This guy makes a whole bunch of them. They're ARM Cortex M4 processors, and they're very beefy. They do program through Arduino. Arduino has some nice stuff, but I'll show you just one thing that's kind of helpful. Watch. I'm going to press pause. It actually paused the code, so if you look over on the video here, if you look over on our screen, it paused. It's no longer blinking. It actually puts us at this point in the code where we're highlighted. There's a little arrow here, and I can put a breakpoint. And those of you who played with Arduinos know that that's not the case. And so I can go and it'll blink, blink, and then stop, and blink, blink, and then stop. The other thing that I can do with this is I can actually mouse over variables. And so if I come over here and mouse over countdown, I wonder if it'll do it for me now. It'll tell me what the actual values in those registers are. So that's a good first intro to microcontrollers and some of the things that are available. There's so much available you won't believe it. And we'll talk more about the guts and the internals of what we're doing here in a minute.